Anytime you see this symbol here, parallel lines, this symbol means these lines are parallel. Which lines are parallel? LA, this line, and CR. So if these two lines are parallel, there's a very easy idea that you want to think about. This line over this is equal to this line over this. So let's just put in the numbers here. This line over here, EL, is given to be 7.5 and CL is given to be 3.5 and then EA is given to be 9.5 and then this value is asked of us, the AR. Let's call it X and just let's put a ratio. So as simple as this. This over this is equal to this over this. So let's just write it down. 7.5 over 3.5 is equal to 9.5 over x. Now, anytime you see this kind of an equation, you simply cross multiply. So 7.5 times x is going to be written over here, and this is equal to 9.5 times 3.5. Now that value here is equal to 33.25. So let's just write this as 33.25. Now you simply want to isolate x, so you divide by 7.5, you put it here, and this value is equal to 4.43 blah blah blah. Now if you can round this, you will get 4.4, and so that's your answer. Very, very easy to solve. Now it's your turn to solve this problem. Suppose this length EL is 15 and this length is 5 and this is 21. Then what is this value AR? Again, you're going to do the same thing. You're going to write 15 over 5 is equal to 21 over x, and then cross multiply and find the value of x. Post your answers in the comments so I can see if you can solve this correctly. All right, let's move on. This is a very standard similarity problem. Remember, you've got these two lines are parallel. This symbol means parallel, of course. So you've got DE, which is this line, and it's parallel to BC. As soon as you see this parallel thing, you just want to think about similarity. Which parts are similar? This triangle is similar to this triangle. So let's draw it out a bit. So here, this ADE is written over here, and then ABC, I've just redrawn this over here, and they are similar. What does the similar mean? This symbol over here, it means that this ratio divided by this ratio. So you've got AD over DE, which is also what they've gotten over here, AD over DE, is equal to the exact same thing over here. This left over this base over here, which is AB over BC, and that's it. This is equal. In fact, this is also equal to AE over AC, but that's not important here. You've got AD over DE is equal to AB over BC. Well, this is out, but this is precisely what we want, and so therefore 2 is the correct answer. Now it's your turn to find an answer. AE over AD. Remember, AE over AD over here, or AE over AD this way, is equal to what over AB? Very easy. AE over AD is equal to what over AB? Very easy to answer. So comment your answers what this value should be. Okay, so you're given two triangles over here and you're told both of them are right triangles. Both of them are 90 degrees. So this angle is 90 and this angle is 90. And then you're given that AB is 5, and then you're given AC, this length over here is 12. And then you're also given, in this other triangle, you're given DF is 12, and then you got EF is equal to 13, and you're asked if they are similar. Now look, you already got this length as same as this, and you've got this angle as same as this. So all you need to find out is what is this length. Let's call this B, and let's use the Pisach theorem for it. So let's go for it. Let's try, this is 13 and this is B over here. So how do you do it? You got 12 squared plus B squared is equal to 13 squared, and so now you've got 144. 12 squared is 144 plus B squared is equal to 169. You subtract 144 over here, and this value is equal to 25. 169 minus 44, 144 is 25, and so therefore B is equal to 5. And there you go. In place of B, you can put in 5 over here. Now you simply have to compare and use one of those postulates. So you've got 12 is the same as 12, so this is the side part. This angle are both 90 degrees. So you've got angle, and then you've got this side is equal to this side, and so you've got SAS, and so therefore Brett is indeed correct. These two triangles are actually congruent to each other. Now you work your magic on these problems and try to prove that they are congruent. How would you do that? You've got 12 is already equal to 12, and you've got some missing pieces here. So you already got an angle. What about finding this value and then finding this value and trying to use the SSS property, or you can use AS property, or you can use the hypotenuse length. You can use any of these three to prove that these two triangles are congruent. So post your answers in the comments on how you would do this. I'll be waiting. This is a great exercise for proving something, to prove that these two triangles are congruent. Now, which are these angles? You've got this triangle EAB, this is this triangle, and you want to show that this is congruent. This is congruent to FDC. So that's FDC over here. Now, how do we prove this? So let's get started. The first thing is AE is parallel. This is a symbol for parallel to DF. So if AE is parallel to DF here, you want to draw the transversal this way. Remember, these are the parallel lines here, and this is the transversal. If this is the transversal, if you tilt your head around, you'll see that this angle is equal to this angle, and that's the important part. This angle is equal to this angle. This is the alternate interior angle, right? So this angle is equal to this. We're just going to leave it like this. Now let's move on to the next part. EB is FC. I'm going to use a different color for this. Let's use EB. This line is parallel to FC, like so over here. So if these two lines are parallel, let's draw this transversal again. Let's draw this transversal again, and then think about it this way. Again, you want to think about this angle is equal to this. Remember, these two are parallel lines over here, these two, right? And so therefore this angle is equal to this. How is this equal? They are alternate exterior angles. So therefore this green angle is equal to this green angle over here. Now the final thing, you want to prove this triangle is equal to this triangle, right? You almost have the angle, and you've got another angle here. Now if only you can prove this side, you're all set. So let's get started in proving this side. These sides are equal. So how do we do that? Let's try to think about, we've already used these two ideas. Now we only have this remaining. AC is equal to DB. So AC is equal to DB. Let's just write it down. AC is given, is congruent to DB over here. Now what is AC? You can split this AC into two parts here. This AC, you see this length over here, is equal to this part plus this part. So let's write that as AB plus BC, and this is congruent to, this part is congruent to, again, you've got DB, which is this length over here. I'll use another different color here. You've got this length, and you've got is equal to DC plus BC. So you can write this as DC and then plus BC over here. So you see over here you've got BC, which is the same length, and you can just get rid of them. You subtract BC on both sides, and there you go. You've got AB is now congruent to DC. In other words, you've got this length here is equal to this length here. So remember, you've got all the pieces of the puzzle now. You've got this angle is equal to this angle. You've got this angle is equal to this angle over here, and then you've got this length is equal to this length. So now it's up to you to do the final step and post your answers in the comments. How will you show that these two triangles are congruent? What is that property? What is that blink postulate that you will finally write to prove that therefore these two triangles are congruent? So post your answers in the comments, and let's see if you finally totally understood this problem. This is a very standard similarity problem, even though there's no similarity mentioned here. Remember, you're given that this triangle, this ABC, is reflected over this line. So whenever they're saying it's reflected to get this triangle, it's just a code to say that this triangle ABC, this length, this triangle over here, is just simply congruent to this other one, which is triangle DEF over here. Now what's the big deal with this? The thing is that when these two triangles are congruent, or even when they're similar, you can simply write down A is equal to D. This first letter is equal to the first letter here, which is D. Then you've got this second is equal to the second, so B is equal to E, and then the third is C is equal to F. C is equal to F. Now, of course, they're asking us what is the measure of F. So if you can somehow find out the value of C, then you can find the value of F. So let's now, in the second step, let's try to find the value of C, which is extremely easy to find. So how do we find the value of C? Remember, you're given more information here. You're given A is equal to 40. So this is equal to 40 degrees. And then this B over here is given to be 95 degrees. So of course, in a triangle, if you're given two angles, how do you find the third one? You just sum them up and make it equal to 90. So 95 plus 45 plus how much is equal to 180. Now this 95 plus 45 is actually, my bad, it's 40 here. 95 plus 40 gives you 135 plus how much is 180. So of course this value is 45 degrees. So C is equal to 45 degrees, and therefore because C is equal to 45, this F is also equal to 45. So F is also equal to 45 degrees, and so therefore 2 is your answer. Now you try to solve the same problem to find f, but with a different measure. Suppose a is not 40 anymore, a is equal to 30 degrees over here, and then b is not 95 anymore, b is a different number, b is equal to 100 degrees. So remember, using this, first you want to find out what is the measure of c. So find out what is the measure of c, and then using this idea, try to find the value of f. Of course, it's none of these answers, but try to post your answers in the comments. This way you'll have more practice. All right, this is a very standard question. You're given that you want to prove bxy. So there's this kind of a triangle, and then you've got this bigger one, this BAC triangle over here, this BAC, and you want to show that they are similar. Now, how do you show they are similar? This is a very, very standard question. If these two triangles are similar, then all you need to know is that these two lines are parallel. Many tests will ask you this question. If these two lines are parallel, then these two triangles are similar. So all you need to do is look inside this answer. Where do you see these two lines are parallel? XY is parallel to AC, and you see XY is parallel to AC as the answer, and so this is a correct answer. Now you try to solve this problem. Let's see if you understood it. You're given that NO is parallel to PQ. In other words, you've got this length over here, this length, this line is parallel to this line over here. It's parallel. Then which two triangles are similar to each other? Remember over here what we did, it's this triangle similar to this one. That's the hint for you. So which two triangles are similar over here? And then just post your comments and let's see if you understood it. So in this question we're given two right triangles. So of course there are right triangles here, and this is ABC over here, this is A, B, and C, and this length is given to be 4 here. This hypotenuse over here is 4, and then here the hypotenuse is R. Of course this triangle is RST, and then this hypotenuse over here is 16, and you're told that they are similar. So once they are similar, you can easily find out the scale factor for this. So this is 4 to 16, and when you simplify this, it becomes 1 to 4. So let me just simply write the scale factor as 1 to 4. 1 is to 4. Now this is a scale factor for every length. This length scale factor for, in other words, this is 4 times this, and this is 4 times this. So of course any one-dimensional linear thing, the ratio is 1 to 4. Even the perimeter is in the ratio of 1 to 4. But now if it becomes a two-dimensional thing, like an area, like this area and this area, then that ratio is going to be the square of this number. So you get 1 squared to 4 squared, which you can write as 1 squared is 1, and this you can get as 1 to 16, right? So 1 to 16. So the area is in the square form. So now you're given this 1 to 16 ratio. So that is the ratio of the corresponding areas. In fact, if this was like a volume problem where you had like a three-dimensional thing, then you would actually cube this. You would get 1 cubed to 4 cubed, and then you can simply write this as 1 to 64 would be the ratio of some kind of volume of this ratio of these similar triangles. Now it's your turn to solve this easy problem. You're given these two triangles and you're told that they're similar, and then the thing that you're given is this length over here is 3 and this is 15. Now this is 3 and this is 15. So of course you know the scale factor is easy, 3 to 15, and then you can find it out. You can simplify it, 1 is to blah blah blah. And then the question for you is, there are two questions. What is the perimeter? What is the ratio of the perimeter? Remember, the perimeter is a linear measure, so what would be it? And then of course the second value, the second question for you is, what is the area? So of course find the perimeter, something to what, and then the area also what to what. So post your answers in the comments. This is really going to help you memorize this concept. This is an excellent problem to understand congruence and similarity properties, especially understanding ASA, AAS, etc. for parallelograms. Remember, this is a parallelogram over here. So what does that mean? You've got this length is parallel to this length. Okay, once you have this, what are they asking us? First of all, they're asking us EMB is similar to FMD, which is this part is similar to or congruent to this part. How do we show this part is congruent to this part? So you just basically want to look at the angles inside it. So therefore, let's start with this part. You've got this line is parallel to this. Why is it? Because this is a parallelogram, and you want to think about this as your transversal. These two lines are parallel. This is your transversal. So now if you have this, which two sides are equal? Which two angles are equal? This angle is equal to this. There are many others as well, but this is the most important one because it's inside these two triangles. So that's why you only want to look at these two triangles, these two angles over here. Now the other thing, the other side here, this line is also parallel to this side. This side, these two sides are also parallel because it's a parallelogram, right? Opposite sides are parallel. Now what are we going to do is we're going to look at this transversal over here. So remember, these two lines are parallel and this is a transversal. Now only inside this triangle and this triangle, using this idea, which two sides are equal? You want to think about it this way. This particular angle is equal to this angle. That's not true. You've got this angle is equal to this angle, and then when you subtract this particular part, this angle is equal to this angle, then you're left with one important idea, that this angle is equal to this angle over here. All right, so we're almost done now. We've got two angles here, and then you just need the third thing to tell us. But of course, there's one more important piece of information we haven't used. Line EF is drawn such that it bisects. Bisects means cuts DB into two parts. This is DB, and imagine this is a scissor that's going across it. It cuts this into two parts, which means this length is equal to this other length over here. So I can mark this is equal to this. So now, of course, you've got, if you just mark it over here, you've got angle, it's my bad, you've got angle, side, and then you've got the green, red, and orange. So angle, side, of course, works. So using angle, side, you've shown that this actually is true. But there's one important thing that we can also do. We've got this angle here is equal to this angle. So in other words, this angle is equal to this. Why is that? It's vertical angles. So there's no real property of parallelograms used here. It's just that these two angles are equal. So if these two angles are equal, now you want to see, would ASA also work? Think about it, and then you want to see, of course, AAS works, but you want to know if ASA also works, and then if both of them work, then which of these choices would be correct? So post your answers in the comments. Remember, probably both of them would work or only one would work. So let me know what you think about this, and I'll wait for your answers. This is a great multi-step problem to understand a lot of similar triangles. So first of all, you're given ATV is equal to ABC. So ATV is this angle over here and ABC is this angle. So if these two angles are similar, remember, if these two angles are similar and you've got lines over here, that means this line is parallel to this line. And if these two lines are parallel, a very, very important thing happens, and that is these two angles, this triangle and this triangle over here, they are similar. The smaller one and this bigger one. So this smaller triangle and this bigger triangle, they become similar because these are parallel lines. So that's the first step in this problem. Now let's draw these two triangles, these particular two triangles, and try to find out how to further progress on this question. Okay, so we've got these two triangles. Now the smaller one, I'm going to write it down as ATV, and this bigger one, this is ABC. Now all you need to do is try to do the ratios. So first of all, AT is equal to 4 here, right? And now you want to find out, you're given BC, this length over here is 18. So I'm going to write this down, 18 over here. Next, I'm going to write down TB. This length is 5 over here. But if this was 4, then remember, if this was already given to be 4 over here, this is 5, then this total length is 9. And so I'm going to write this length 9 over here. All right, so I've used up this part, I've used up this part, I've used up this part, and then AV, which is over here, is 6. So all you need to do now is you want to find out what is this length, find out this length, and then you can find out this quadrilateral. So let's proceed methodically. Let's try to first find out this length over here. Let's call it X. Okay, so how do we find this now? You want to just use similar triangles. So you got 4 over 9, which I'm going to use this over this, is equal to X over 18. You can easily see this is 2 times 18, so this is 2 times 4. So therefore X is equal to 8. So now this is very easy. So let's make this 8 over here. This is going to be 8 this way. All right, so 4 times, because 9 times 2 is 18, 4 times 2 is 8. That's one quick way you can think about it. Okay, now the next one, you need to find out the final length AC. So how do we do that? We've got 6 over here. So again, maybe you can try the same thing. You've got 4 and 9 over here. You can write 4 over 9. This over this is equal to 6 over Y. 6 over Y. And now you want to find out Y. You always cross multiply it. So you get 4Y. So this implies 4y is equal to 9 times 6, which is 54. Now 4y is 54, so y is equal to 54 over 4, which is 27 over 2, and that gives you 13.5. So let's write this down clearly. This final length over here is 13.5. Okay, now let's kind of like redraw this part here. So we've got this triangle. Let's redraw this part here. So I'm going to draw this line like so, and then they're asking us to find the perimeter of this particular part here, this part over here. So you've got 18 already, and remember this is 9, so this part is 5, and then this length over here is 8 over here. So you're going to write down 8 over here like this, and then this part is given over here, which is 13.5, and you already know this part is 6, so you subtract it and you get 7.5, and of course you've got 18 here. So remember, we've done a lot of math, so try to recreate this problem and find out. Now you know the perimeter of quadrilateral TBCB, which is this particular part here. So now it's up to you to find out the length. Remember, all you need to do is add these and then post your answers in the comments. Which of these answers will work? So I'll wait for your answer. Remember, the most important idea is doing similarity on each of them and then finding the answer. This is an interesting problem which will really test your similarity skills. This is an easy problem here to solve. Remember, the first important thing is that these two lines are parallel. EF is parallel to HG. So this is parallel to HG over here. But anytime you see this parallel symbol, the first thing that you should think about is similarity. Which two triangles are similar? This triangle is similar to this triangle, but they're similar in an interesting way, and I'll show you how it's similar. But before that, let's fill in these values. So you've got EF is equal to 5, so I'm going to write down this is 5. Then HG is equal to 12, and then you've got these two FI, this part over here is equal to, this length is equal to 1.4x plus 3, and then this length over here is 6.1x minus 6.5. Now, how are they similar? Let's look at them here. This is going to be similar to this, so therefore you write down 5 over 12, and then here you're going to write down, remember this is a smaller triangle over the larger one, so therefore similarly you've got this smaller over the larger one, and you take the ratio of it, so you write down 1.4x plus 3 over 6.1x minus 6.5. So remember, smaller over larger is equal to smaller over larger, and remember this is twisted here. This is not similar to this, this is similar to this one here. Now it's easy, you just simply have to cross multiply. So let's cross multiply it. You get 5 times 6.1x minus 6.5, and that is equal to 12 times 1.4x plus 3. You're just cross multiplying it, simple. Now you distribute each of them. So how do you distribute it? You got 32.5 times this is 32.5x, and then over here, my bad, it's going to be 30.5x over here minus this times this, and that gives you 32.5, and this value here, 12 times 1.4, that value is 16.8x, and 12 times 3 you know is 36. So now let's bring this 16.8 here by subtracting it. So you subtract 16.8 and this is gone, and then this guy you bring here by adding it, so add 32.5. Now when you sum this up, the value that you're going to get is 68.5. So let's write it down here, 68.5x, and this value, my bad, it's going to be equal to 13.7x here. And this value here is going to be 68.5. So dividing by 13.7 on both sides, so you get this is gone, and so x is equal to 68.5 divided by 13.7, which is equal to 5. So x is equal to 5. So all said and done, you actually got the value of x to be 5 here. Remember, the most important idea is this concept over here. You have this ratio. Once you have this ratio, everything is all set. You just cross multiply it. So you got x is equal to 5, but that's not the answer. The answer is, what they're asking is hi, which is this length. So now let's see if you can plug this value inside and calculate the exact answer. That's the practice for you. Which of these answers, clearly 1 and 5 are out, so which of these two values is going to be equal to, when you plug this answer inside, the length of hi? So post your answers in the comments and let's see if you can solve it real quick. This is a very, very common question on many geometry tests. Remember, if you're given these pipes over here, this parallel to DE is parallel to BC, then there's only one thing you need to do. But let's look at what is DE and BC. DE is this line and BC is this line over here, and they're parallel. As soon as you see they're parallel, there's only one thing you need to think about, and that is similarity. That is this symbol. And which triangles are similar? It's this triangle over here, and this triangle is similar to this second triangle over here, this triangle over here. So ADE is similar to ABC. You just simply want to figure out this ADE. Just even write it down, and then this bigger one is ABC, and just write down the similarity in front of it. And you just want to seek out the similarity symbol. And there you go. ADE is similar to ABC, and so therefore 2 is your answer. Now it's your turn to find out which triangles are similar. Remember, in this problem, in this new problem, I'm saying TS is parallel. This line means parallel, of course, to RQ. RQ. So TS is parallel to RQ, which means this is parallel to this. So now the question for you is, which two triangles are similar? So write them down. Blah 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 is equal to or similar to blah blah blah. So post your answer in the comments and let's see if you can solve this real quick. This question is a superb example of all the congruency tests for triangles. Remember, when you're trying to prove the triangles are congruent to each other, right? This symbol, how do you prove them? There are four tests of congruency. One of them is the side. In other words, the sides, all sides are same. Then there's the side angle side. So you've got the side and the angle in the middle, and then the side. Then you've got the angle side, and then finally you've got the final one, which is the angle side angle. So these are the four important tests of congruency. And then there's a fifth one, which is the side angle. This is wrong. This is commonly tested. If you ever find this one, this is incorrect. And so now let's get started with each of these triangles now. So this first one here, you've got this length is equal to this one, right? That's the first thing. The second thing is this angle is equal to this angle. So you've already got side, you've got angle. And then the last thing you want to do is this over here is this side is equal to itself. It's the reflexivity. So you've got side, then you've got angle, and you've got side. So you've got SAS over here. So this works. All right, let's move on to the next one now. Over here in this part, you've got this side is congruent to this side, is equal to this side. Then the second one is this side is equal to this one. How about the third one? The third one is right here. This is congruent to this one. So this is congruent to this is congruent to this is congruent to itself, the reflexivity. So you've got S over here. Now let's look at the third one over here. You've got this angle over here is equal to this angle is equal to this angle. It's already given to you. This side is equal to this side, and then you've got another angle which you would just want to see. This angle is equal to this angle. Why are they equal? Because of vertical angles. So these are vertical angles over here. So now what do you have? You have angle, you've got angle, and then side. So you've got angle, and side over here. And let's look at the last one here, which is the last one over here is going to be this side is equal to this side. You've got this side is equal to this side, and this angle is equal to this angle. So here you always go either clockwise or counterclockwise. So this is side angle. So you've got these four properties now, these four tests over here. Now you want to post in the comments which of these, only one of them is incorrect, because they're asking you which does not prove it. And remember, we've already talked about it here. So if you're paying attention, let me know which of these 1, 2, 3, or 4 is incorrect. You cannot, in other words, you cannot use it to prove congruency. So post your answers in the comments and wish you the best.